Hello everyone, my name is Ramón. I'm a site reliability engineer at Google, where I support the identity services, which is a crucial service for all the services and customers around the world that the company has. I have been working at Google for the last 9 years, and I have been managing incidents for some time, creating some myself. So I'd like to talk to you today about how we do incident management at Google. So to set the stage, let's just think about this potential case. So it's Friday, all your rollouts, all your deployments are done for the week, you are more or less wrapping up, but suddenly, prior to go for a refreshment with your colleagues, the pager goes off, all your systems are down. So what happens? Because all your customers are receiving 500s, your users around the world are not able to access your services, and you need to enter into a mode of responding to this outage that is just triggered into your production environment. The first step that I recommend you for having a successful incident response is to not panic. You have been supporting the services for a long time. Probably you developed the services yourself. You understand perfectly how they work. You know how the company operates. You know that you have your colleagues close to you if you need to ask questions or if you need to ask for help. So panic is the worst of the ingredients that you can have for a successful incident response. It will make you stressed, will just make your judgment not be complete, and not considering all the options that you have at hand for resolving the problem that you have. So let's just look into what an incident looks like. So in this section, I'm going to go through the anatomy of an incident, meaning like we are going to be looking like what an incident is and how we can go through it. So first of all, the first acknowledgement we need to have about incidents is that all systems will break. You will have systems that they are designed for the highest reliability targets that you can imagine. For example, in my own part of the world at Google, we have services that they will have 5 nines, 5.5 nines of regional availability, of global availability, etc. So they are services that they can only fail like a few seconds even in the year. But we do have outages that they happen into these services. We are trained, we are maintaining good documentations, we are having response mechanisms for precisely these cases, and you can too. Systems will break probably between two options that we have at hand. So there are incidents that they are change induced. For example, you have just rolled out a new version of your binary. You have just changed some configuration. There is a new backend that has been enabled in your production stack, etc., etc. These are the most common. Up to 70% of the outages that we have at Google come from changes that we do in our infrastructure and changes that we do in any layer of infrastructure. For example, we can change a cluster management configuration or some templates into our frontends, and both might trigger some performance regression, some privacy incident even. Those are really bad incidents as well to have. The other option that we have is process-related changes. So, for example, you might need to deploy new capacity. You might need to transfer some of the data from one of your clusters that you have in Europe to a cluster that you just deployed in the United States. You might need to, for example, deploy new classes of machines that you are just buying for your on-prem infrastructure that they were supposed to be more efficient, but they might have some side effects into caching or into contention. Whatever it is, those might trigger a degradation or a reduction of performance in one of your components and might end up having what we call a cascading outage. That is a small component affecting a bigger component and so on and so forth until the whole system is down. For example, you might have a quota error in one of your services that takes down the whole Google search, even if the first system was thought to be safe and smaller. Luckily, all problems have solutions. As I said, you are the one that is best prepared to respond to these issues because you are the one that knows better your service. So, first of all, let's think what is an incident anyway, right? Because if you are supporting a service, either because you are an SRE or you are a developer that are doing support for your own service or your own product, you will see that you have many times in the day, you will receive a ticket, you might get a page, there might be a customer that escalates to you some issue that they are having, but not all of that is really an incident, right? So at Google, we consider that an incident is any class of issue that we have with our products, with our services. That can be a production incident, for example, a service being down, that's a pretty visible kind of incident. But you can have as well privacy incidents if there is some misconfiguration or something that is happening with the user's data. There can be a security incident as well. Or even there can be an organizational incident if something is going on. I remember that our VP event trainer, when the COVID pandemic started, sent a note and declared an incident for how we were going to transition from going into the work from home mode, which was a challenge at the time, not only for us, but as well for our customers. That as well can count as an incident. Incidents are escalated, meaning that the first responder is not typically able to solve it by themselves. So, for example, if you have a person that is on call, they get a ticket or a customer escalation, and it's something that is not very clear for them to solve, they will continue and escalate to other layers of the support. Incidents as well require a very immediate response. You can just have the incident that we are handling right now, the Google page at Friday, 2 p.m., and just leave it for Monday. Because if all your services are down, that's a pretty reckless thing to do. And finally, incidents require an organized response. So at the same time, we said that the first responder, so the person that was in the on-call rotation and got a page or a ticket or a customer escalation, for example, was not able to solve it. To solve the incident, you might need to pull in more people. You might need to pull more SREs. You might need to pull some developers. You might even need to pull some managers for like managing some organizational issue. Anything that you need will be at your disposal for the incident response. At Google as well, we use some heuristics to determine when something is an incident. Because if I'm Paige, for example, I have been in my team for a few years. I know very well my systems. Well, or I think I know the systems very well. I might be tempted to say, like, I'm going to resolve the incident by myself and not have to declare like one whole incident response with my teams and so on. However, I use some heuristics. For example, if I have a very big user impact, for example, if I have, 100 million users, that is something at Google that can happen, affected, certainly that might be an incident. Depending on your user base, you need to like tune what is going to be the user impact that you use for guidance for the responders to have an incident. The same happens with revenue. For example, if you're running your Google Ads or whatever is in your equivalent in your company, you might want to say like if, 10% of the daily revenue is affected, you might want to consider that an incident, right? These are all heuristics, and they are things that they are arbitrary at some point as well, because you could consider 5 or 15, depending on what is your tolerance to risk as well. Another heuristic that we have is like for infrastructure teams like mine, that we are technically not serving users directly, but serving the rest of the products that we have in the company. We are going to use how many teams are we impacted. So if we are just impacting, for example, for one of our outages, just a singular customer, like for example, this problem is only affecting Gmail. Perhaps it's not sufficiently localized for us to try to resolve it. If this is affecting many teams, like search is down, Google Cloud is down, Gmail is down, Workspace is down, that certainly is an incident. As well, one thing that we do at Google is categorize the outages or the incidents that we are responding by these heuristics in just 3 categories. So anyone that is reading it, like other teams, like executives, like developers, can make a sense of like what is the impact of the incident that is being responded. For example, we might have minor outages. Those we might need to have a coordinated response because there are many teams affected, or is something that is complex, or is something that has been hanging for a few hours as well. That's another dimension for deciding to have another coordinated response. We have major outages, things that affect multiple products, a lot of revenue affected, for example. And then we're going to have huge outages. Huge outages, we don't have many. We might have, in my team, one every other year. So reserve the huge outages for the actually really huge ones. But if you're taking down the whole company, that's a huge outage. I recommend to use it. This is great as well for analysis. When you are analyzing all the outages, all the incidents that you have had in your company, you can classify and see what are the products that they are affecting more the reliability of the rest of the company, etc. The categorization of the outages can be changed at all points in the response. So you might think at the beginning that is huge, and then just discover that it was not that bad, so you just move it to major, and that's it. That's fine. So now that we know what an incident is, how we respond to it, So the first option that we have, that is the naive way to do it, like what our body would ask us to do, is do an unmanaged response. So if I get the page, I would want to actually debug my service to try to fix it, to try to solve the problem that I have. Right? The problem is that is not very effective. For what? For what reasons? First of all, I would start freelancing. So I would start resolving and investigating and trying to mitigating the outage by myself. My colleagues, when they see the service down, they will try to help because it's the right thing to do. But they are going to do the same. They will try to freelance. And I would be looking at the quota system. Someone else is going to be looking at the configuration of the templates. Someone else is going to look at the performance of some backend, try to see. Then we will start communicating because I would see that everyone is trying to respond. So I'm going to put what I'm doing in the IRC. Someone else would go to our chat to put what they are doing. We will not see each other. And then someone else will try to say, like, I'm going to open a document where I can type, for example, the commands that I'm typing in my terminal and the outputs, for example, for doing some posteriority analysis or doing some forensics for later. But no one of the three of us would be looking what the other is doing. And then the response will be narrow because I would be looking at a singular part of the system. For example, I was looking at the quota service, and then I would eventually realize that it was fine and move to something else. My colleague that was looking at the performance of the backend would just be looking at that backend, but not, for example, at how the relation of the different backends and the storage would go. Could be that a complex system interaction is actually the one that is making the system break, not one individual component by itself. So, what do we do at Google for managing incidents? What we do at Google is like we have a method that is called Incident Management at Google, IMAG, that defines some very specific roles. These roles are inspired into what the first responders in other physical world, let's just say, incident response they do. For example, firefighters, for example, paramedics, etc. So the first role that comes to play is the incident commander. Every incident response has an incident commander. Typically, what we do is to have the responder that got the escalation, the person that was paged, the one that got the problem at the beginning, be the incident commander. The incident commander is the person that will have a view of everything that is going on. So we'll have the context of like how the escalation happened, what services are affected, what is the impact in our customers or users, what are the investigation paths that they have been tried, etc., etc. They by themselves will not be investigating and typing commands in the terminal, but will be having all the state of like the things that they are going on. Roles other than the incident commander get assigned by need, depending on the class of outages that we are having at hand, depending the size of the impact that we are having in the company, depending on the teams that they are affected or the customers, we are going to need to have the rest of the three roles or maybe not. So many of the incident responses that we are going to be doing are only going to have the incident commander and the operations lead. The operations lead is the second role that comes to play. So when you have to coordinate a response that has multiple people, like for example, you have the incident commander and 5 other persons or 10 other persons if it's a complex issue that you have been escalating along the way, there is going to be a person that needs to coordinate that everyone is busy doing something and is doing something that is useful for the stage of the incident response that you are at. For example, if the incident commander says like, I think we need to look at the logs to find out if there are some requests with some properties, right? So the operations lead would make sure that someone is actually looking at the logs, that has the proper access to retrieve the logs, that is able to have the resources that they need. For example, if we use things like BigQuery to process all the logs, you might need to have an accounting user to make sure that there are resources for your queries to progress and to be successful, and so on and so forth. As well, the operations lead will make sure that the results from the investigations that everyone is doing will come summarized and will come to the incident commander timely so they can make the next call of like what is going to be the next step. So if the log analysis is not successful, they want to say like what they saw, if there was something that was weird but it was not what they were expecting, for the incident commander to see what are the next steps. Other role that is very important that we typically is going to use but not always is the communications lead. When you have an outage that is affecting many consumers that you have of your services, is affecting many users around the world, is affecting, like for example, if you are a business to business kind of company, you might have like executives of the companies that they buy your services on the phone with your own executives asking for what is happening because their own business is affected. Your own executive will call your incident commander and say like, hey, I have a platinum customer at the phone. They want to know what is going on with the Google platform that is currently down. If you leave that to happen, this will distract the incident commander to actually think about the incident, the response, and what are the next steps. So the communications lead is a role that is going to be actually tasked to incorporate all the information of the incident response that is going at the moment. Like, for example, what is the impact? What is the current state? What is the current steps that we are taking? What are the next things that we are going to try? Consolidate the information and inform all your other teams that they are affected for the incident, that they have the services down, and then it's going to put together, for example, summaries that we can publish for the external customers to read what is going on. So a customer that sees a response that is transparent, they say like, look, our systems are down, this is what we're doing, this is the stage we are. They typically end up trusting more your services because they see a responsible response than someone that doesn't know what is going on, right? The communications lead as well will interact with other teams inside the company. So, for example, if my identity services would be down, many of the other services that we have will not be able to function because they cannot authenticate users. In this case, the communications lead will talk with Gmail, will talk with search, will talk with cloud and say like, this is what is happening, this is the things that they are trying, and these are the next step. We don't have an ETA for resolution yet, or we do. Or even we have a mitigation, right? So that will be very useful for the rest of the teams as well. And then we have the planning lead. The planning lead is a role that is thought for the aftermath of the outage. So once we have our outage mitigated, we are not bleeding and our services are running again. We even might have a permanent fix in the pipeline that is going to be rolled out in a new version of the binary, in a cherry pick, whatever it is, right? Then starts the hard part of saying like how we are going to prevent this outage to happen ever again, because that's the objective is like we are going to have outages, but at least we're going to have them only one time. So the planning lead is going to look into what happened, like the root cause. It's going to look like how was the response. It's going to look, for example, at the timeline of events that happened in case we can change our processes, in case we can change our way of responding to outages. Perhaps we need to modify our incident management protocol if that's the case. So the planning lead is looking mostly about the aftermath, right? In this case, as well, one of the things that should be expected is from the outside. So the planning lead is going to be working with partner teams for the services that were customer or backends of us to see how we can make the infrastructure better so this doesn't happen anymore. These teams, they should expect clear communications during the outage and after the outage as well. So they should expect a postmortem to come that has all the summarization of the timeline of events, the root cause, impact, proposed action items that is signed off and reviewed by our teams and our executives. One thing that the outside teams they should expect as well is a handoff eventually from one responding team to another. When you are responding to an outage for a few hours, you're going to be tired. It's a stressful situation after all. And you are going to need to make judgment calls all over the way. And you are going to need to understand that the responsibility on the response is on you, especially if you are the incident commander. After some hours, 6 hours, 8 hours, 12 hours, depending on how you have set up your on-call rotation, a new team will come, a fresh team that doesn't have a state on the outage. So there is going to be a handoff moment between 5 minutes to half hour where the current response team is not responding to the incident by itself, but is transferring the state of what they are doing, where they are, what are the problems, what is the status of the mitigation to a new team. That's fine, and it's not a problem. It's actually part of the response. So during the response, one of the priorities that we are going to have is to mitigate the bleeding. This is how an incident looks like. So a problem is created at some point. It doesn't materialize to the users until there is a trigger where the damage starts. Then, after a few minutes that the damage is showing up to the users, an on-call person is going to be paid. And then this person will have to decide what they do. Should they prioritize mitigation or should they prioritize fixing the system forever? At Google, we strongly recommend to prioritize mitigations. For one reason, mitigation is something that can be done even in some generic terms. So you can have processes for rolling back a binary, rolling back a configuration push, deploying emergency capacity, having rollback for changes in your permissions, in your configuration of your oracles, etc. If you maintain training in your team and if you maintain good documentation, people immediately will understand what you mean. So if you are the incident commander and you say like, hey, we need to roll back this binary, your responders, your operations leads perhaps, will just know where the documentation is or what is the automation system that they has to trigger to get the binary to the previous version that it was, for example. This will not fix your issue. This will just mitigate what is going on. So your customers, your users will just see the system serving again, which is good enough because at least you will not be bleeding anymore. And what is happening is that you are going to have much more time to actually investigate and deploy the actual final mitigation. If you go through the other route in the fork and you continue investigating, you will end up finding the final fix. But you don't know how much time this is going to take. Your medium time to repair, the MTTR, will be longer. Your users will have a longer window of times where the service that you are providing is not working. And it could be the case even that by the time you have the permanent fix, it's too late. So worst case scenario could be a security incident when one of your services is vulnerable and you are going to have a very long window potentially of time where your service is exploitable by external entities or hackers or whatever it is, right? Or you might have a storage system that, for example, ends up corrupting data. So I strongly recommend focus on the mitigations, fix permanently just later. So once you are there, and you have your mitigation in place, you are not bleeding anymore, then you find your commit that you need to roll back, or your bug, or any change that you have to do to your CI/CD, so the test will actually catch these regressions. What do you do next? What is the aftermath? Are we done? No, we're not. So the postmortem is the major artifact that you have to get after the incident response is completed. So the postmortem is a blameless analysis of what happened. We are not fixing people. We are fixing the processes around the services and your team that you have, or the design of certain components of your stack. So whenever we have a change, whenever we have capacity deployment, whenever we execute a process that was not working well, the system will either prevent us from doing it or catch it and degrade gracefully, so there is not an outage or there is not a breakage that is seen by the customers that we have. It's very important that the postmortem addresses the root cause, and the root cause is not the trigger. Usually they are confused because the trigger is what happened, so the actual problem, the root cause, gets exercised. For example, a common root cause is some commit that went into the repository, right? That had a bug, for example. It's not the fault of the developer that wrote that code. We all have written bugs. I write them all day. The root cause is that problem that was not catched by your testing, for example, that your CI/CD was not able to run an integration test so you could exercise that code. That's what you want to fix. That's what the postmortem needs to focus on. Then you have the planning lead enter into the stage again. So the planning lead will actually coordinate what is the long-term response. You are going to have to track all the action items that they are in the postmortem. It might contain from tens to even hundreds of action items distributed in different teams. For example, your team might have like plenty of action items to improve your own service, but as well, your backends could have a way to provide you with service that is more resilient, or your customers even might want to handle your own service in another way, adding retries, adding another way to have some cache, for example, whatever it is. So if you are down, for example, the impact on them is lesser. The planning lead will have to help with the scoping. And what we mean with the scoping is to see what is the actual impact of the outage. This usually can only be done after the fact, when some of the logs are settled and some of the forensics that we can do can happen. So we are going to need to count, for example, what are the users that we had affected, what is the impact on the revenue of the company, what was the impact on the data durability that we have. Depending on the systems and depending on the outage that you are handling, the scoping of the impact will be slightly different. And finally, something that is relatively hard is working on prioritization with the different teams. So we are going to have different teams that has a completely new corpus of work that they need to address with high priority. So you are going to need to alter the roadmaps of these teams, that they have the staffing they have, potentially for their product development and the features that we want to provide to our customers. But now suddenly they have to work with high priority in some reliability work that is actually for an outage that was triggered by another service, right? So these are conversations that they are had. At Google, we have many programs to make sure that reliability is at the top of our priorities. We have reviews with executives, for example, to make sure that they understand what is the status of the resiliency of production so they can themselves prioritize the work in their own teams. So the priority work and efficiency work gets actually worked out along with the feature request. And you need as well to balance, like, obviously, if you have a system that is too unstable, that has a lot of feature development, might not be very useful because it's just not available for the users. But if you have a system that has seen only reliability work, you have a system that is perfectly available, but perhaps it's not that interesting for our customers too. So you have to see where you put the balance. So finally, to make the audience remember that all systems break, even the ones that they have the highest reliability standards, all systems are going to break. Some systems will break because of a very spectacular failure. Some other systems will break at some point because of a small component that was sitting in the corner, just doing a small thing that was triggering into a cascading outage. At some point, some systems might break because the operator was typing something that the system was not prepared to catch and to prevent. And that's okay. You just need to fix your testing, for example, in this case, right? But the nice thing that you need to remember is to not panic because all problems have solutions and you are the one that is most equipped to fix the issue that we have. At Friday, 2 p.m., but probably at Friday, 3 p.m., you can still have your refreshment with your colleagues. Thank you all.